In this video, you'll be seeing how to make your own robotics car using Arduino, and we'll be covering basic movement using motors and how to use the ultrasonic sensor when you assemble your first robot. This is the Elegoo car kit, and it's what we'll be using for our tutorial today. Even though it has a pre-existing program, you can just overwrite it with normal Arduino code and it functions the same. By just following their step-by-step instructions, you're able to finally create your Arduino robot. Now enough of that, let's get started with the coding. First, go to Arduino's website and download their IDE. It should look something like this. Now for today's objectives. First, we just want to make the robot move, and then we want to worry about avoiding objects. It's helpful to know some of the components before we start working with them. So we have DC motors controlling the robot's movement. This is the battery pack. This is the ultrasonic sensor. It sends out an ultrasonic pulse. That's called the trigger. And then it listens for the echo that it gets back from an object over here, and then uses a calculation to see how far it is from that object. Now over to the brains. This is the Arduino Uno R3, and that's doing all the calculations and running the code where we upload it through here, this port. And this is the IO expansion shield. Elegoo likes to call this the smart car shield, and essentially this has an integrated motor driver, so it gives us the functionality to interact with all these motors, and they all get plugged in through different pins on the IO expansion board. Hi, I'm up here now. So this is a simple program where the robot moves forward, backwards, left, and right, and you have to define your IO pins before you start using them. So these are all variables, and these are all different pins on the Arduino robot. Now, since we have our motor driver module, it makes things very, very simple. So A in this context means the right side motors, and B refers to the left side motors. PWM means pulse width modulation, and essentially you can't turn a motor to a certain speed. What you can do is either turn it on or off. So to give the illusion of speed, you make it on and off very fast, very quickly in a short duration, which gives you that speed variety. And you could use the value 0 to 25 when controlling speed or power, but I just use high and low throughout this entire program. A in means the direction of the right motor, and again it uses high and low. And B in controls it on the left side, the direction of the motor on the left side. Now since the motor driver is an H-bridge, it also has the standby functionality. So if the standby is on low, nothing can move, and if it's on high, then everything has the ability to move. Not necessarily that it will, but it just has the ability to do so. Void setup runs before the car actually starts moving. So you need to set all the pin modes to output, because right now you only define variables. And then you use digital write. Digital write provides that power to those pins. So you are providing high power to the standby pin to allow the motors to run. And then you're providing low power to the right and left side, because you don't want to move forward yet, you just want them to be on. This is the main loop, and it keeps repeating with a delay before and after everything. And there's also functions here which allow the motors to move in a certain way. So let's take a couple examples. Void move forward into duration. It takes an integer duration for the delay, or how long it's going to move forward for, and it uses digital write once again. So to move forward, you want the direction of all the motors to be going forward, and I like it at the fastest speed possible, so I set them all to high as well in these two lines. And then you need this delay here, because if you don't have this delay, it'll immediately execute the next piece of code, so it won't actually move forward. So you need this delay, so it runs this digital write, it goes through the delay, and then it'll start moving on to another function. And move backwards is essentially the same thing. You're just setting the direction to reverse by using low. And for something more interesting, let's say turn clockwise, in order to achieve this, you have to set the right motor direction to reverse. So you set A in to low and B into high. And that way you can turn clockwise, and again, it's full speed ahead. And by using all of these functions, you can make the car do this. This is the second program, which is supposed to avoid the walls of the arena. And once again, we define the I/O pins, but this time we also define the I/O pins for the ultrasonic sensor. And remember how I said that there's initially a trigger, the sound, and then there's an echo, it picking up the sound to figure out how far it is away from that object? Well, we have to define those pins as well. And then we also define some other constants as well. For example, the threshold in centimeters to detect obstacles, or how long turn should be in milliseconds, or how long reversing should be in milliseconds, and also the speed. We want it to be a little bit slower, because if you go super fast, the momentum might just cause you to crash into things. So once again, you assign the pins, but this time around you also assign the pins for the ultrasonic sensor. The trigger is set to output, but the echo this time is set to input because you want to get the information from that echo. And in this main loop, you first collect the distance, you measure the distance, and if it's within a range, then it prints out a couple things, and then it reverses and turns around to avoid that obstacle. Otherwise, it just goes ahead very slowly. Now let's go through these other functions, starting off with the more simple ones. Reverse and turn, it's similar to what we just saw, just a little bit more complex, but it's essentially the same things. Same with move forward slowly, it's just that we are changing the amount of power we send to the pulse width modulator A and B, so that way it moves more slowly. What we're really interested about is this measure distance function. At first, we turn off the trigger to make sure that there's no signal going around, and we wait for a little while before we send out another trigger. And then we wait again for 10 microseconds, and then we turn it off to make sure that we don't have any errors when we collect information. And then this pulse in function gets the readings from the echo pin, and it turns on that pin. And in 20 milliseconds, it collects all the information that it gets and the distance. And if the distance is something other than 0, then it just returns this part over here. But if it is 0, then there's nothing in front of it, so you can assume that it's a very large distance. Now, why are we doing this calculation over here? Well, it's because this constant is used to convert the reading we get by factoring in the speed of sound through air, and then dividing it by the amount of times it needs to cover that distance, which is twice to also make the return trip. And then after creating my own arena with a bunch of objects that I found around my room, this is what happened. In conclusion, you've now learned how to make an Arduino robot move and the theory behind it, so you can start constructing your own programs, doing your own objectives, and I know in just a little while you'll become a robotics master with Arduino. And anyways, until next time,